For the practice problem that she gave out in the other class, we have this prove that n to the 4 minus 5n squared plus 8 is equal to the theta of n to the 4. So we're basically trying to find which two bounds would give us this to where this equation is in the middle of both of those, given C1 and C2. So we're going to use this formula down here to find C1 and C2, and we'll write it out with our order, which is N4. And C2 into the 4th. So now we're going to choose a side. She's starting with the right side. So now we're going to copy it again. And we'll leave some space so we have enough space for the intermediate. And then, so if we need this side to always be less than or equal to this side, we have to get rid of the negatives on this side. So we're going to remove that negative 5n squared. So we're only going to have n to the 4th plus 8. So then our next step is to convert this 8 to be the same order of n to the 4th. So we're going to multiply by n to the 4. So then we can combine it later. So now combine it. So now we have 9 n to the 4. And you know you're done because you have C2, which is a constant number, and n to the 4. So our 9 is our C2 and n to the 4. And to get your n naught, this is when you add the number. So we only added n to the 4. We're assuming that this number is positive, greater than 1. Because we are needing this left side to be less than or equal to this right side, and our input can only be greater than or equal to 1. So that side's done. Now we can do the next side. So now we have the same thing, but instead greater than or equal to, and then greater than or equal to C1 into the 4th. So now to do this, we need the left side to be greater than the right side. So we're going to remove the positive this time. So we're going to have something like this. Then we need to get these to be the same order. So we're going to multiply by n squared to get into the 4th, which will be n to the 4 minus 5n to the 4, which will give us negative 4n to the 4. Now, this is wrong because we need this C1 to be a positive number. So we can't do this. We'll have to limit this when we get it to the next order, so it's still a positive number down here. So usually I pick this coefficient and multiply it by 2, so it'll be 10, so over 10, and then n to the 4 minus 5 over 10 into the 4, so it'll be 1/2 n to the 4 when we simplify it. So this is your C1 and this is your n to the 4. C1 is 1/2, and your n naught in this case, you look here with what you added, we need this to be positive. So when would this be greater than 1? N squared, so 1 squared over 10, that's not greater than 1. 2 squared, that's 4 over 10, still not. 3 squared, that's 9 over 10, no. So that'll be greater than 1 when n is 4. So that'll be 16 over 10. So your n naught will be 4. So to write your answer, you take your C1, which is half, and then your order less than or equal to your original equation less than or equal to C2, which was 9 into the 4. And this is for all n is greater than or equal to n naught, and we're going to pick the higher one, which is 4. And that is the answer, and that's the proof.